Hello everyone, welcome to my talk with the title A/B Testing for Applications. So let's dive right in. Let's start with some sort of a definition from potentially your experience around what is A/B testing. And then we'll go ahead and take a look at some more specific examples and what are the benefits of it and what we could potentially be careful about. So here's an example, a recent example as of maybe 2-3 months ago from a launch that Facebook did regarding its dark mode version of the web app that most of you are probably familiar with. So what happened was that Facebook decided to have a new version of the app, and they created this new darker mode that you see at the bottom here. And then what was happening for some time was that some of the users and some of your friends may have potentially been stuck with the light version of the app, so they were saying this part, while some other people were saying actually this latest part, the darker part. And then as Facebook was actually doing that, it took some time until everyone basically switched to the newer dark version. So this is an example that you may have been familiar with. This is one example of A/B testing. So what Facebook was doing in this case is that they were having two versions of the same app, one dark, one light, and they were A/B testing. They were testing the two versions to ensure that everything was working as expected, and then for example, no user metrics were hurt in any way by the new version of the app. So what is then a more formal definition of A/B testing? It is essentially the experimentation with two or more variants of an app or a feature so that we can collect enough data to check out exactly what is happening, which one of the two variants or two or more variants is best. And then based on the data that we collect, we're going to make a data-driven decision as to which variant to adopt. And that data-driven decision is based on looking at different metrics of performance. For example, in Facebook's case, they might be looking at, let's say, number of logins per day, or length of the session, or how much money they were making from the ads, and a whole bunch of other things. A/B testing is not a new idea, especially in software engineering wraps, and you may have heard it with various different names, such as bucket testing, split testing, left testing, ABN testing. This is essentially the case where we'll be testing more than two variants. A/B typically refers to two versions of a feature or an app. Multivariate testing, where we are testing more than one variables at once. This is rarely used. It's pretty complicated to actually get the useful conclusion out of it. Or flights, some companies call it flights. And the premise of all of this is that we want to trust the data. We don't want to be flying blind when it comes to actually launching a feature or launching a new app. Where in the development cycle does A/B testing fit in? Well, we basically want to be thinking about the development cycle as something that is basically constantly evolving. So in some sense, the typical software engineering cycle would be starting with the design, then moving ahead to development of the ideas or the feature or the app or the desktop application, whatever you would like to do, then test it and then release it to the public. And then basically at some point after the release, then product managers or customers or whoever, they come up with new ideas, and then we would go back to design, develop, test, and release to everyone. Now, a couple of things here that we want to be improving, and actually this is a new paradigm that a lot of companies are currently embracing, is that after the release, we just don't let our code or our app to go wild out there, But instead, what we're doing is that we are constantly measuring and collecting data or telemetry, as you might have heard, around the performance of the app. So we're checking to see how long users stay with the app, how many buttons or how many clicks does it take them to do a specific task, how much money we're making per user, and so many other things. Then we analyze that data and we learn our lessons. For example, the new app may have actually be causing a lot of delays for a user to be doing a specific core function in the app that was kind of unexpected. But in any case, the idea is that we do some analysis on that data and then we go back to the design. Of course, we're going to be taking into account the opinions of our product team and the feedback from the customers, but there's also the notion that we're actually measuring how our app is performing on the fly in real time in production to inform our design. And of course, through this A/B testing, the interesting thing is that we don't just develop a new thing and just let it go to everyone, but we can actually do it slowly. So we release it to some of the users and we test to see that everything is according to plan, while we leave the remainder of the users to the previous version of the app. As you may know, this whole idea of A/B testing is applicable in an abundance of use cases, ranging from ads. We have a new relevance algorithm that determines which ad to show to which user in retail. Should we show you this kind of picture versus that other kind of picture? User interface, should we have the buttons on the right or on the top, or should we be using this picture versus that other style sheet? Apps, recommender systems, should we recommend you this movie versus that movie, and so on. So basically, options here are honestly limitless. Now, how does it work in practice? What is like the high-level idea behind it? The basic idea is shown on this figure. That is actually an example from the ads platform of Facebook. So basically what we're doing is that we're looking at the user population that we have, and we want to randomly split the users in two or more variants. Here we're showing two just for simplicity. It is important to do this randomly because if we don't, if for example we do based on location or based on some other metric, and we split the population like that, then we're going to get results that may not be representative of what is happening with this experiment. So we randomly split the users in two variants, and we have a feature or two versions of a feature, version 1 and version 2. And then in the first group, we're showing the version 1 of the feature, which could be also the existing feature, in which case we call that control. And then version 2 is the new thing that we would like to test, to examine or experiment as to how better or worse this may be. So we're showing half of the population version 1, half of the population version 2, and then we're measuring, and we want to ensure that what we're observing is statistically significant. If, for example, version 2 is showing, let's say, 10% increase in revenue, we want to ensure that this is really the case and we're not just seeing a temporary effect or temporal effect, but this is actually that is going to hold if we actually release version 2 in the whole population. So we analyze the data and then we decide what to do with whatever conclusions we draw out of the analysis. For example, one approach may be to say, well, version 2 is really awesome, therefore now we want to release version 2 so that it's visible to everybody. Or we may decide that version 2 is not really that great, so we're going to keep version 1 and then iterate on version 2 and improve it and then maybe test it again. Now, why do we care about A/B testing? Well, in a lot of cases, it actually involves significant gains, not only in money, as we jokingly show in this picture, but in a lot of other metrics, such as user happiness, Net Promoter Score, NPS, as you may have heard. Of course, revenues we discussed, leads that you might be getting, clicks, successful email campaigns, sales, and so on and so forth. So, in general, A/B testing is the scientific way that you can use to prove that there is a causality of a given idea that you may have within your app, instead of just measuring correlation. So, with A/B testing, you can actually show that this new change or this new idea that you may have for your product, for your app, is actually indeed causing the numbers to go up or down, rather than this is just a happenstance that the new feature for some reason coincided with a change in your metrics, but one is not actually causing the other. A/B testing is really a de facto standard in a lot of other sciences, and most notably when we are studying drug effectiveness, which drug works, which one does not. This is a typical situation of A/B testing. We are having the placebo, the no drug or fake drug, and then we have the real one, and then we're measuring how many people actually got well or got better. Now, A/B testing in general is very easy to adopt and can provide you with a lot of benefits, as we're going to see in a bit. And it's very easy to adopt once we provision for it. Of course, it requires some infrastructure in the back end, and you may decide that you want to write it yourself, which is a little bit tricky, but not impossible. But if you actually see the benefit and you want to use it, then there are a lot of different platforms today that allow a lot of developers to actually implement A/B testing within their apps and have a data-driven approach to their apps. Here are but a few. I'm just listing the top ones like Google Firebase or Amazon Personalize or Azure App Service Optimizely, but there's a whole bunch of others. It's just too many to list here, and there's also in a lot of cases you can find open source code as to how to do that. And when it comes to actually implementing it and putting into your applications is basically really simple. So here are two versions of pretty much the same idea. Very, very simple code. So what we're doing here is that assume a user came in and their user ID is stored in this variable, user ID. So what we're doing is that we're getting the variant. We're basically telling the system that, hey, you need to decide whether I should be showing this user, let's say, version 1 or version 2 of the app. And if this comes back as variant 1, then an example I'm using here, a simple example, is changing the text of a button to have a learn more or sign up caption. So if the variant comes back as variant 1, we should be showing version 1, therefore the button text should say learn more, otherwise it should be sign up. And now the tricky part is that we of course need to log which variant the user went in, because we need to remember that. And then we also need to log, exactly what happened right after that. For example, that we assign this user to variant 1 and then look at the different metrics for the specific user. How many clicks we got, how many people actually gave their email, and so on and so forth. On the right, there's a version of the code. This is pretty much the same version, just a more generic version where you could have like more than 2 variants. This function, you could actually wrap this caption assignment to a function, and then you could be doing a lot of more complicated things that assign a specific text to this button. But as you can see, it involves a few lines of code here and there. Of course, you can complicate this as much as you want, and you could also simplify it as much as you want. But this is, again, the basic idea. And remember, again, the trick here is that we want to remember the variant that the user ID went in, so that we can actually analyze the results in a proper way later on. Now, as I said, you can choose, one could choose to implement it themselves, or you could choose to implement a customized, super amazing tech stack for A/B testing. I'm showing Netflix's tech stack here. Of course, Netflix is a different beast than compared to, the average developer, the average application that is being run. But this is so that you can see exactly what this involves. Typically, there's a REST API where a service or the app or some other service calls and says, hey, I have a new user, please give me the variant. There's a bunch of different functions that are happening. We're keeping metadata. We actually want to remember the variants. For example, Netflix here is using EV cache. We're going to be doing sampling because we don't want to allocate all users to the experiments. We may want to keep some to let them be, especially for the cases where the new feature is revenue sensitive. We don't want to mess everything up. And then we can have a pipeline for either real-time or near real-time analysis. For example, Netflix here is firing events on Kafka based on what is happening with the A/B test, which can get analyzed by Spark. And then Netflix also has this Ablaze tool for visualizing exactly what is happening. Again, this is a complicated tech stack because Netflix is running hundreds, if not thousands, of experiments a day. And other companies like Google, Microsoft, LinkedIn, Amazon, they have their own things. And again, you're not expected to implement something like this. If you wanted to use A/B testing, you could just utilize something existing. But this is more so that you understand what exactly it involves in the backend. Now, let's look at some interesting examples and why this whole A/B testing thing is actually making a lot of sense. The first scenario here, and since elections is actually a very recent thing, is this Obama's $57 million button. So in this example, what happened was around 2007, Obama was running for election for president. And then what they wanted to do is they had a website where people could go in and they would sign up and say, well, I'm interested in signing up and helping or getting involved or getting informed. And then based on those, they would actually, Obama's people would try to convert these emails, these leads, to actually donations, right? So people would give their email address, and then the Obama's people would reach out to them and potentially try to get them to give some money, to donate some money in Obama's campaign. Now, initially, the campaign was designed, as you see on the left picture here. And you may think that this is reasonably good looking, and you might be clicking on it. But basically this involved two things, two major elements. The first one was the media, which is what picture we're actually showing to the people. And the second one is which button we're actually showing to the people. And the question is this the right media, or is this the right button? Or maybe both? Should we change both? So, for example, alternative options for the buttons were this join us now, learn more, sign up now instead of sign up, and then obviously sign up that we have. Now the question is, if we had an option of pictures and an option of buttons, which one would actually make more sense to use, or which one is more effective? And instead of sitting down and thinking about it, what Obama's people decided to do was actually try and run all those possible combinations. And when they did, they had a dashboard that looked like the one that you see here. So basically they ran the different variations here on the top. They ran the different variations of the button, the original button, then it said learn more, then it said join us now and sign up now. And they actually split the visitors pretty much equally, and then they checked to see how many clicks they would actually be getting based on the different variation of the text in the button. So as you can see here on the top, learn more was actually the one that showed the 18.6% improvement compared to the original default version that they had. And it actually, you would see here that they were looking, the key metric that they wanted to optimize upon was this conversion per visitors. Similarly, when they run different pictures, instead of just showing Obama in this blue picture that we just saw, when they were running different pictures, they also observed that if they showed this family image, then that one would show a 13.1% increase in conversions. So now what they did was that they basically took these let's say 3 different variations of the button and these 5 different versions of the media, and they ran a combination with every button and every media, and then they measured exactly which one is performing the best. And what they ended up doing is that they decided that based on the metrics and the actual data that they collected, this was the best combination to use. So they used this family picture that we just saw was the best converting one, and they also used this learn more button that was also the best converting one. And as a result, they managed to get $57 million more in donations. They actually managed to collect a crazy amount of money compared to the leaving the default version that they had. Now here's another example. So as you know, search engines are showing people ads on the top, and in a lot of cases in those ads, we're showing a link and then there's some description. So in 2012, basically an employee at Bing suggested to change the ad format. So instead of just showing the description at the bottom here, they wanted to actually put it next to it. So basically ads got shortened and they got like a longer link. Now, interestingly, this simple idea, when they A/B tested it, actually triggered a whole bunch of alerts that it might not be, that something strange might actually be happening. But it ended up being, the alerts ended up being correct. And what happened was that with this simple idea, they ended up earning like $100 million more per year simply from the ads. Some other interesting examples is Amazon's credit card offer. So Amazon used to offer a credit card, but they would be doing so early in the funnel. So basically, once you would come in a lot of cases, Amazon would say, hey, would you like to apply for this credit card? But then someone came up with the idea of actually showing the credit card right before checking out, where you can actually see some savings because you're getting some discount. And they A/B tested that, and they saw a tremendous conversion lift, in the sense that way more people would actually apply for the card at that point versus showing it randomly at the beginning of the funnel. Another example is Bing at some point decided to tweak the JavaScript that it was using for his home page, so that the shorter HTML would be sent back to the user, and in this way, things would show to be faster. As a matter of fact, they launched that, and it was so successful that it turned out that the amount of money that they would be making through this faster HTML, 10 milliseconds of improvement in the loading time translated to actually being able to fund a software engineer for a year. It was the salary of a software engineer for a year. Third example is Google's 41 Shades of Blue. You may have heard of this. So basically, when you go to Google and you input a search, there's these blue links, but actually the exact hue of blue that is being used has actually been tested very, very significantly, because apparently different shades of blue have different conversion rates. So Google experimented with very small things, even whether it should be blue or bluer or less blue, in order to identify exactly which hue of blue they actually want to have on their links. Now, one toy example to just kind of get us going into this thinking in an application would be the following. In an application using A/B testing would be the following. So let's say we're running an online service, and we're worrying about engagement, which we can define as, let's say, how many times within a week a given user came back to our service. So if a user is using our service, our online service, let's say a game, once a week, then it's probably a low engagement user. If this user came back 7 out of 7 days of the week, then it's highly engaged. So we can split, as we said, our users based on the engagement, high, medium, low, and we can study their characteristics. And now what we're being asked to do is to figure out, how we can increase user engagement, as we said. So what we did was we did some analysis on the data we have, and then we found that highly engaged users are actually paying more for our service. They are spending more time per session. They have more friends, and they chat more. So now someone is asking us to increase our engagement, but and we have these indications here that they're paying more and spending more time and have more friends, and they chat more. So what should we do? Obviously, we can come up with ideas around these findings, and we can say, well, we need to make people paying more. But if the causation is the other way around, in other words, it's not because people are paying more that they're highly engaged, but it's actually the other way around. Because they're highly engaged, they're paying more, then simply making everyone pay more is not going to cut it. We're not going to see any result. So question now here is how we can come up with ideas to identify causation versus correlation. Again, for example, highly engaged users are going to have more friends because they're highly engaged. They're going to chat more because they're highly engaged, not the other way around. By making people chat more, you not necessarily are going to convert them. So how would we go about doing that? So typically, the A/B testing steps would be following such a scenario is to come up with a hypothesis. For example, we could come up with a feature that, let's say, you get some credits if you connect with, let's say, 10 friends. And the hypothesis here is that if you connect with more people, then you are going to become highly engaged. That's our hypothesis. That's what we want to test. Then next, we want to create the variance. In other words, we want to determine whether we're going to be running one version of this idea or many versions of this idea. For example, here we could say we wanted to check whether there's any difference between asking someone to make 5 friends to connect with 5 friends versus 10 friends versus, let's say, 20 friends. Now, another question would be how many users we want to run through this. One idea would be to have just everyone run through. Another idea would be to have way less people run through. We want to analyze the results in an interesting way. We want to determine when to stop. Typically, we want to stop at the end of the experiment. And then we're going to repeat adjust our A/B testings until there is termination of experiment. In certain cases, we can stop early. That's usually the case when we're going to abort versus waiting all the way to finish the experiment. And typically, we call this idea that we have a treatment. Then we split the users in cohorts. Some fraction of users says the treatment, some says the control. The control is typically the application as is. We run the test to completion. We check again for statistical significance, and then assuming everything works well, we want to switch everyone to this new feature. Now, one question is whether we're going to always do that, but as we're going to see, this is not always the case. Now, when it comes to statistical significance, I'm not going to go into all the math here, but depending on the example case that we have, we can do different kind of statistical tests. This is a field in statistics that is well studied. Just this table here summarizes what you may want to do, depending on the kind of problem you're studying and the kind of metric you're studying. Now, as we said, once we test the variant and we decide that something interesting is happening, we want to make a decision as to whether we want to move everybody to this new treatment. So here's one example with numbers where the treatment involves a cross-selling of a power drink that shows a 3% increase in revenue in the A/B test. So we checked versus the control, and then we showed everybody that came into our online service an ad for a power drink, and then we saw a 3% increase in revenue, right? So now the question is, given this data, what should we do? Well, the obvious approach would be that we want to be selling the power drink because, cross-selling the power drink because we're seeing a 3% increase in revenue and we're going to make 3% more money. And of course, we assume here everything is statistically significant and all works fine. But actually, in certain cases, it actually helps to look into the data a little bit more carefully. For example, it could be the case that, yes, of course, we do see the 3% increase in revenue, but if we actually go and dissect our data, and let's say we're looking at male versus female population, and there's a 50-50 roughly percent split in how many males and females came in. It could be the case that for males we're actually seeing a 5% increase over control versus a 2% increase in control. So 2% decrease. Now, the question here is that in this case, what would be the optimal strategy? Well, it turns out that in this case, we may actually want to be showing this cross-selling only to males, because in this case, in this way, we'd be realizing the 5% benefit that we have, and we would not be realizing any of the loss that we're getting in the female population. So the lesson learned here is actually that, yes, A/B testing is good, but you always need to go and dissect your data and analyze it to actually see what is happening, rather than just blindly following the metric that you might be interested in. Now, some potential pitfalls. I just showed you one. It's not really a pitfall. I mean, you would be still be realizing the benefit, but there's additional things that one needs to be careful about. So one such pitfall is the user arrival patterns. For example, what happens is that early in a lot of cases, if you look at the results of an experiment very early on, you are seeing what is happening with very engaged users. You are seeing what is happening with the users that are showing up every day. And you may want to actually give it some time before a representative population of the users are actually coming in. A second pitfall would be the temporal effects. Day of week, Sundays people might be shopping more versus Monday when they are at work. Season, well, is a Christmas, then people are going to be shopping more versus summer, that they might be shopping less. When you also have real-time apps, for example, if you wanted to A/B test algorithms for finding for giving you a route on the map, it's kind of tricky to actually find two users that are going from the same place to the actual same destination in order to do A/B testing. So in these cases, this is a little bit challenging. Third thing would be privacy and novelty. On the right here, we're showing one silly example of actually primacy and novelty. What is happening in this case is that we're seeing a picture where it has a fake hair on it, and people are actually being tricked into removing the hair from their phones, and by mistake, they're actually tapping on the ad. So primacy novelty is referring to the cases where a new feature is so novel, is really new, that people are trying it out, and you might see a lot of clicks and a lot of traffic going into that feature, but then it's actually not doing anything over time. So in certain cases, you may have to wait for the novelty effects to wear off because actually measuring anything. Social connections is another interesting kind of tricky situation where if you actually split the population in a social network in two, it gets a little bit tricky because you might be in one variant, which, for example, you might be seeing a new feature, but then your friends are not seeing that feature, and it's kind of confusing because you might be actually trying to interact with them through that feature. They don't have it, or you talk with them offline, and it gets confusing. Another pitfall is the delayed deployment of an app. So this is an example where someone comes up with an interesting A/B testing in their app. They code it, it's good to go, and then it has to go through the App Store, or Google Play Store, or Google Play, and then what is happening is that you are in this kind of state where, let's say, some of the people have upgraded their app and some of the people have not, or there are two versions behind, and now you have to actually do some measurement, and it gets kind of tricky. And then there are other kind of interferences, such as budget. You may want to be careful about how you split the budget within the different variants. If it's geo interference, there could be that some people, if you have, let's say, a global application that works around the world, for some people is noon, for some people is midnight. You have to be careful about what you're measuring there. Or even networks, some people may have slow networks, some people may have faster. You may want to account for that when you're measuring different things. Now, in conclusion, in general, we talked about A/B testing, we talked about the basics, but the truth is that A/B testing can be viewed as a stepping stone to what is actually called continuous intelligence. Continuous intelligence involves basically real-time analytics, where these analytics are integrated into business operations directly, and they look at all the data that we're collecting, real-time, current data, historical data, to automatically come up with actions and decisions that respond to what exactly is happening in the system, and they can be making business decisions or different application decisions in an automated way. In other words, the future of this is that a lot of apps and a lot of organizations are going to be running in a continuous testing mode, in a continuous intelligence mode, where things are being tested on the fly all the time, and then the system automatically adapts in a interesting way, in a good way, based on the metrics and based on the data that has been collected. And with that, we conclude the talk. Thank you very much. I'd be happy to take any questions you may have.
Thank you very much for that great talk. I have a couple of questions. Well, there's one question here. The Obama example is a great way to illustrate the importance of A/B testing and evaluation in general. Thank you, Alex. Alex, do you know of any local examples of A/B testing that might have happened in sort of local campaigns here in Greece, for example?
Yes, there's basically quite a few ad companies that are doing A/B testing through Google platform and a whole bunch of other platforms that allow them to do, Facebook specifically. In general, a company that is specializing in doing A/B testing that I'm not aware of in the Greek market, it would be an interesting opportunity if someone wants to tackle that, I guess.
Fantastic. And any open source tools you might want to refer our visitors to that they might want to test with?
Not something specific. Actually, the biggest challenge is basically coming from the fact that you need to have some backend so that you can actually collect all the data that you're looking at in every application. So writing up a open source tool should be trivial. That's probably isn't something I could at this point recommend. But the tricky part is coming from the backend, as I said, to do the analysis and actually kind of integrate it back with your app.
Okay, fantastic. Again, thank you very much for that awesome talk.
Thank you for inviting
I expect
me.
people will see you in the chat windows.
Yep.
And enjoy the rest of your day.